Hello, grade 6. Today for math, we are doing a review of the last chapter. I know we've kind of slowed things down a bit with writing portfolio, so we're just picking back up with some of this stuff. So if you feel confused, don't worry. I'm going to go in deep explanation for each of the vocabulary words, and then I'll explain the rest of the pages you need to do, and then you can get to work. So if you were able to print these pages out ahead of time, please copy in all the answers to match the vocabulary, add some notes. I really encourage that. If you did not print it off, you weren't able to do that, that is okay. You can pause the video at any time to get all the answers written down, copy the definitions, and add your own notes, okay? So I'm gonna share my screen with you so you can see this first page here. I have all the vocabulary already up and I have the answers. So I'll zoom out. If you want to pause, this here would be a good time to copy all of these and then continue listening to the video so you get the further explanation. All right, I'm going to zoom in here so just so you can see a little bit better. Number one, I'm also going to grab my pen just for any notes. All right, so we have equilateral triangle. Equilateral means the same. Another word for the same or equal is congruent. So let's look down at our definition. J, a triangle with three congruent sides. We know a triangle is a shape that has three sides. For it to be equilateral, it needs to have the same length on all three sides. Number two, composite figure. We talked about this yesterday. We talked about this on Thursday. A composite figure is a figure made up of two or more three-dimensional figures. So you can't just have one, that would just be a normal 3D shape. For it to be composite, you need at least two or more. It can be any 3D shapes stuck together. Now, yes, on Thursday, we learned how to find the volume of that. You just split them back up into their own shapes and then add it all together. So composite figure, two or more three-dimensional shapes. Parallelogram. Now, if we don't remember, parallel means lines like this, lines that never touch. They're not crossed like this. They will never cross. They will always go straight on forever if you don't stop them. So a parallelogram, let's scroll down to I, is a quadrilateral. Remember, quadrilateral means four, quad, four. So it's shaped with four sides, and the opposite sides are both parallel and congruent. So the sides going this way are parallel and congruent, and the sides going this way are parallel and congruent. They can be slanted. They don't need to be straight. They just cannot ever touch. Otherwise, it will not be parallel. Number four, volume. On Tuesday and Thursday, we talked all about volume. To find volume, you need to sorry, I keep losing my pen. To find volume, you need to do length times width times height. But what volume actually is, let's scroll down to K, is the amount of space within a three-dimensional figure. So if I have a 3D shape, volume is telling me how much space is inside here. Number five, a rectangular prism. We all know what a rectangle is. It's a shape with four sides. They don't all need to be congruent. A prism is a three-dimensional shape. So let's look at A. A three-dimensional figure with 6 rectangular faces, 12 edges, and 8 vertices. So here is a rectangular prism, just about. I mean, it has a little indent in here, but that's okay. So faces are around the sides. There are 6 rectangle faces. 1, 2, 3, 4, 5, and 6 on the back. 12 edges. Edges are where the faces meet. So there's 12 edges around this shape. And then vertices are the points where they meet. 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. That's a rectangular prism. 3D rectangles on all sides. Now, number 6, a regular polygon. A polygon is another word for a shape. Regular remember, means that they have to have all congruent sides or all equal sides. So a regular polygon is a polygon or a shape with congruent sides, equal length of the sides, and congruent angles. So like an equilateral triangle would be a regular polygon because all three sides are equal and all angles are equal. Number 7, closely related to number 5, we have triangular prism, G. This is a prism, a 3D shape with 2 triangles at the base, triangle here, and then we have 3 rectangular faces on the sides. So a prism with 2 congruent triangular bases. If you just see one triangular base, that's called something different. That's not a prism. It has to have a triangle on the top and a triangle on the bottom. Number 8, obtuse triangle. A triangle with one obtuse angle. Now, obtuse means greater than 90 degrees, bigger than 90 degrees. Obtuse is bigger than 90 degrees. So an obtuse triangle just needs to have one obtuse angle, one angle that is bigger than 90 degrees. Number 9, a face. We just talked about this. The face is the flat surface of a 3-dimensional figure. So we have 6 faces on a rectangular prism. The face is the flat part. Number 10, a polygon. Scroll to D. A closed figure made up of line segments that do not cross each other. So, like I said earlier, polygon is a fancier word for shape, but there are some rules that it has to be for it to be a polygon. Closed figure means it can't be open like this. This is not a polygon. Those are just some lines. So it has to be closed, and the lines cannot cross each other. If they cross each other, it's also not a polygon. Number 11, a square. This is a rectangle with 4 congruent sides. We all know what a square looks like, but the definition is that the sides are all equal, congruent. And a pentagon, number 12, I'll go up to F, is a polygon with 5 sides. Penta means 5. Okay, so I'll zoom back out if you want to pause and write down any of these definitions. Let's get this out of the way. If you don't have this printed off already, pause here, write down all of these definitions. So then when you work on the next few pages, you will not have any confusion, okay? So I'm gonna turn our answers off first. Turn to page 980. So I'm just gonna go over these and then you guys can stop the video and start working. This one says to name each polygon. Determine if it appears to be regular or not regular. So name the polygon means tell me what it is called. Count the sides and tell me what this polygon is called. Determine if it appears to be regular or not regular. Refer to our definition of regular back there, okay? Describe the attributes of each quadrilateral, then classify the quadrilateral. So these are both quadrilaterals. They have 4 sides. You need to describe the attributes. You can tell me if there are parallel lines, if there are congruent angles, equal angles, or not congruent angles. And then you need to classify it. Which kind of quadrilateral is it? There were a couple examples on the last page. Now, this one, or these 2, describe the faces, edges, and vertices of each 3D figure. So tell me how many faces, the flat surfaces, how many edges, the sides, how many vertices, the points. Then tell me what they are called. All right, word problems. A triangle forms the front of the Pentagon in Rome, Italy. Here's the triangle here in red. Classify the triangle based on its sides, then classify it based on its angles. So you need to tell me if it has congruent sides or not, and then tell me what kind of angle it is. If it is an obtuse triangle or an acute. Acute means all sides are smaller than 90. Obtuse, it has one angle bigger than 90 degrees. Sean keeps his photo in a box like the one shown. What is the volume? Remember, length times width times height. And make sure you have that label we talked about on Thursday. Ishmael jogs around a track that is in the shape of a regular pentagon. Pentagon has 5 sides. One side of the pentagon is 1/4 mile long. How far does Ishmael jog if he completes 6 laps around the track? Remember, regular tells us all sides are equal. You know one side, you know all of them. If the track was a hexagon, how far would Ishmael jog in 6 laps? Hexagon, 6 sides. Pentagon, 5. Now find the volume of the composite figure. This is exactly what we did on Thursday. You have the 2 3-dimensional shapes, find the volume of each, add it together. All right, so I think with all of these definitions here, you should be able to complete the rest of the problems on your own. All right, I'm going to stop sharing here and stop my recording. We'll see you in the next video.